Okay, nice easy question for question 4. So it's just checking that you know that this is a convex lens and that brings rays to a focal point or focal length. This is a concave lens and that's going to spread the rays out. Remember, for this one then, we're going to, I always say to students, draw 2 focal lengths, one in front, one behind. For a convex, we want the one behind. I'm going to go to the middle of the lens, bring that through, wallop, wallop, arrows on it. This one, I'm going to use that focal length there to just get the angles right, wallop, wallop. Now, I've done it a bit neater because I appreciate that that writing is pretty terrible. I agree, it is pants. So, and then later on, we're going to look at this lovely lady here for pick one flower for the focal length. So we've just said, well, this is a converging lens. It focuses rays to a focal point, and it says after they leave the lens. So done. Just make sure that it does cut the principal axis, or it's a posh word for the normal. So this is the principal axis, because that ray will not refract because it's hitting straight on. So both sides are slowed an equal amount. So the next one, we can do that. And I've used a focal point in front to just get that angle right. And the next one, a lens has a focal length of 25 centimeters. Calculate the power of the lens. Well, I don't want that in centimeters, I want that in meters. So divide 100 equals 0.25 meters. Now we're away. Power equals 1 over the focal length. 1 divided by 0.25 equals 4 diopters. On to the next part, we've got 2 solid metal balls, P and Q. What do we need to know? We know that black objects are great at absorbing and great at emitting. White objects are rubbish at absorbing and rubbish at emitting. So good absorber, good emitter, poor absorber, poor emitter. And now we've got a graph. You can see I've put the line in already due to my stupid stigmatism. Makes it tricky for me to read graphs. So each ball is heated to a different temperature. So we can see that P starts there and Q starts there. So it's not the greatest practical in the world. And then it's the ball is then cooled to the same in the same room. So we can see they get to room temperature because it's leveled off at the end, or one of the balls has. Use the graph to show when they were the same temperature. So it's clearly that point where they overlap, and that is 12 minutes. Now, what it'll try and do, it's trying to trick you into going with 10 minutes because you're just being lazy and looking across. So it's read it properly, draw a line, get your ruler out, done. Which of these is most likely to be room temperature? Well, that's this point here. Well, if that's 20, it's got to be less than 20. Absolutely not, absolutely not. 0, absolutely not. It didn't get there, so it's got to be 10. 10 degrees C. Explain why the curve for P is different from the curve for Q. So we just got to have this idea. P's brilliant at absorbing. That's nothing to do with this though, because we've heated it and then it's emitting. So it's this idea, it's a better emitter of infrared radiation or radiation. So the first part, curve P is steeper and has a faster rate of cooling, mark. And the next part is, so P must be the black ball, as it's a better emitter of radiation than white, and therefore it will cool faster. Done.